Hey guys, so in this video we're going to be finding the component form of a vector. So we're going to find the component form and magnitude of vector v represented by the direct line segment that has an initial point, right, at 4, negative 7 and a terminal point at negative 1, 5, right? So let's call our initial point P and our terminal point Q, and so therefore we say that P is at 4, negative 7 and that Q is at negative 1, 5. And if we're trying to find our component form, right, remember that tells us that V equals V1, V2, right? We want to find V1 and V2. And so if we remember from component form, when we don't have a vector that's in standard position, we're going to end up subtracting, finding the difference of our first term, so in this case our negative 1 and our 4, and in our second terms, which are negative 7 and 5, in order to find our V1 and our V2. So let's go ahead and let's plug that in and see what we get. Okay, so we have negative 1 minus 4, 5 minus a negative 7, which is going to leave us with the components for V1 and V2 to be negative 5, 12. And so here we've seen that we have found our first requirement, right? We have found our component form. And so now we want to look and see if we can find our magnitude. Now remember, magnitude is just going to end up being the distance formula, which is the change in x squared plus the changes in y squared, and we take the square root of all of that. So we've already found our change in the x's, right? That's our orange pieces, which means that our change of x's is negative 5, and our change of y's is 12. So we're able to just plug that right into our distance formula, right? So that's going to be the square root of our V1 squared plus our V2 squared. And we have those, so we can go ahead and we can plug that in for our magnitude. All right, so our magnitude of V is going to equal the square root of negative 5 squared plus 12 squared, which is going to then equal 13. And so now we also have our magnitude, and so we have found what we needed to find. We found our component form, which was that V equaled negative 5, 12 in our pointy brackets, and that the magnitude of V was 13. And now we're finished.